Good morning. I'm going to do a little lesson here today about the law of conservation of matter and how you can apply that law to solving mathematical problems with chemical or physical changes. Now, the law of conservation of matter, remember when we talked about what makes something a law is that it is based on experiments. And here you can see in this picture, this is Antoine Lavoisier doing experiments in the lab, because remember, for something to be a law, it has to be based on measured or observed facts. Okay, well, let me tell you a little bit about Antoine Lavoisier. He was an interesting character. He lived in the late 1700s in France. Okay, he was actually an accountant by trade and worked for the king, was one of the high-ranking nobles. You can see how he's dressed very nicely. He was not a peasant. He was a high-ranking noble, trained in accounting, worked for the king. And I think everybody knows what accountants do. They keep track of the money that's coming in and the money that's going out of an account. So from his trade of accounting and the idea of keeping track of everything that comes in and everything that goes out, his hobby that he just enjoyed studying and doing was science. And he got the idea of keeping track of everything that comes in and everything that comes out of any type of change. He did a lot of experiments with tin, heating it in open and closed containers and keeping track of masses. Only someone who's really good with numbers and very patient, like an accountant, would probably have been able to follow through and repeat this experiment over and over with great patience and take a look at the numbers and analyze and realize that when a change happens, that the matter or the mass is conserved. So this led him then, based on this data, to state a law, which is known as the law of conservation of matter, or sometimes also the law of conservation of mass, that mass is not created or destroyed during a chemical change. It is conserved during both physical and chemical changes. So, for example, if you have a 10-gram ice cube and it melts, you're going to have 10 grams of water. If you have a chemical reaction and the reactants have a mass of 20 grams, after the reaction, you can expect 20 grams of products. So the mass of everything before a reaction or change has to be equal to the mass of everything after a reaction or change. And we can take this idea and we can actually write out changes and do some calculations to sometimes figure out how much of a certain reactant was used or how much of a certain product was made. Take, for example, this problem. So it says two chemicals, A and B, are allowed to react to form C and D. So we can kind of put together a little word equation. Now this one we have letters, not words, but we know that A and B react and then they form, and we're going to use the arrow. That means yields or forms. I think you probably remember that from a general science class. C and D. And it says here we have 12.5 grams of A. So we're going to work on writing a math equation and substituting in amounts for the different substances. It reacts with 18.2 grams of B. Now we know that that has to be equal to whatever is formed. We know that we get 8.3 grams of D. It says that right there in the problem. And the question is, how much C was formed? That is your X value. Well, now you have an algebra problem, and a nice simple one at that. You can add the 12.5 and 18.2 and you can subtract 8.3 from both sides, and that gives us an answer of 22.4 grams, and that was then the amount of C that we would expect to be formed during this reaction. Now, some of your classwork today is going to be reading some problems that they described to you in the book. You need to do both things. You need to set up a little equation that is written in either letters or words, and then you need to substitute in the mathematical numbers that would allow you to solve, and then go ahead and use your algebra and solve for that equation. Let's try one more, because this one does have a little bit of a twist to it. This one says, if 25 grams sodium and 19 grams fluorine react to form sodium fluoride. Okay, so let's go back to something that really sticks out nicely. All right, so we know that sodium and fluorine are going to react to make sodium fluoride. Which, yes, that's in your Crest toothpaste if you use Crest. Now, it says that we have 25 grams sodium, 19 grams fluorine, but here's the big thing. Afterwards, there's 2 grams of sodium left over. So not all of the sodium is going to be used up into making the product. I have to take that 25 grams and subtract out the 2, and I see that only 23 grams of sodium is used. This right here, this 23 grams of sodium, that is the number that I want to use, because that is the amount of sodium that is actually going to participate in the chemical change. There was a little bit of sodium left over. Not all of it was used. It doesn't say anything about the fluorine. If it doesn't mention anything being left over, we can make an assumption that it is all used. And then we can solve for how many grams of sodium fluoride are actually formed. And this one actually does say all the fluorine was used. But I think some of the problems in the book, they may not mention a certain reactant. And if they don't mention it, again, that means, hey, it was all used. So I add those two together, and I get that there are 42 grams of sodium fluoride made in this reaction. Okay? So those were just a couple of examples. There's a nice example in the book. Okay? I want you to look in your book at the sample problem that's on page 64. And then on the next page, page 65, there's a couple of problems. Okay? This is your classwork. You may ask for help as needed. Okay? I'll keep the Zoom open. You can ask me for help. You have to do the problems in the Google Doc that's provided. So I have a document that you must open up and put your work there. You have to show your work, which means that I expect to see these two steps. I expect to see words or letters written out, and I expect to see numbers. And then I expect to see a final answer. When you're done with those 4 problems, 6, 7, 8, and 9, and you have asked me questions if you need it and shown your work, you should submit that, because it is going to be worth, okay, 8 points. So good luck with that. What you're doing is using the law of conservation of matter. Remember, it's a law because it was proven with experiments, and you are applying that to changes to solve some mathematical problems. So good luck with that, and remember to ask me for help if you need it.